What is entropy? Entropy is a measure of disorder or a randomness in a system in thermodynamics. It reflects how energy is spread out or becomes less available to do useful work. As systems evolve naturally, they tend to move towards states of higher entropy, meaning greater disorder. In information theory, entropy represents the uncertain or unpredictability of information in a message. A high entropy message is less predictable, while a low entropy one is more structured and easier to compress.
First up is low entropy level. It signifies that the system is in highly ordered state with little disordered and randomness in the system. Just like in our PPT, it shows how ice is similar to this state because the molecules are compact, keeping the molecules in their place.
So, what is entropy level at a medium level? Particles at a medium level have a more freedom to move past one another. It is more disordered than in solids. And as you can see next, that the particles are able to pass by one another in our simulation, which we will get to at the end. As well as here in our figure in our slides, you can see that the particles actually are able to slide past one another.
Let's talk about high entropy. In this state, particles are moving randomly with no order at all. They are freely and rapidly in all directions, which means there's a lot of energy and motion involved. These particles are far apart from each other, and there's no specific arrangement or structure to how they are spaced. This high level of randomness and freedom of movement is what characterizes a high entropy state. You will typically observe this kind of behavior in gases, which where particularly are in constant, which what we call chaotic motion.
So, to conclude, entropy is a way to measure how disorganized or spread out things are in the system. The more random the particles are, the higher the entropy. Solids have low entropy because their particles are packed tightly and move very little. Liquids have medium entropy since their particles can move more freely, and gases have the highest entropy because their particles are moving fast in all directions. Entropy also tells us how much energy can be used to do work anymore. So the higher the entropy, the less useful the energy becomes. Understanding entropy helps us see how energy changes in different states of matter and in the world around us.
Now we have come to the simulation. As you can see, when we go on solids, you can see that the molecules are actually vibrating in one place. But as we raise the temperature, you can see that they start to vibrate more. This is due to entropy rising and to the atoms increasing in energy. Now, we go to the liquid. As you can see, in the liquid, atoms are able to slide past one another. And with the increase of temperature, entropy rises and you can see each molecule or atom going much more faster and more random in movement. Now gas. As you can see, in the gaseous state, atoms are further apart from one another, and as we increase the temperature, you can spectate once again the entropy increases and the movement of atoms starting to speed up.
So that concludes our presentation and simulation. And I would like to ask one of the audience po to question. Sir, how about you po? What's your name?
My name is Sander po.
Okay, so Mr. Sander, what did you understand from our presentation and our simulation po about entropy?
Well, from my perspective, nakita ko yung paano mag-behave yung mga matter dun sa temperature. Pinapalaas, pagdating sa gas, liquid, and solid.
So, do you have any further questions about entropy or any of the theory behind it po?
Wala naman kasi na-explain nyo naman na siya.
Thank you so very much po.
So sir,
ask lang sa, in your opinion, sa low entropy ba, ano yung nakikita yung difference nun sa high entropy based sa presentation natin?
So, nakikita ko doon sa low entropy, nag-i-stay lang yung mga atoms doon, pero nagbabibrate siya. And sa high entropy naman, kalat-kalat siya, nagbabounce back doon sa sphere, and nagbabibrate din siya. Yun lang po.
Thank you.